Next, quotient rule. If f of x and gx are differentiable functions and y equals fx divided by gx, the derivative or dy by dx is the function g times the derivative of the function f minus the function f times the derivative of the function g, all divided by the power 2 of the function g. I'm going to use the notation u and v as before. U as the function for the numerator, and v is the function as the denominator. So u divided by v for the function y. The dy by dx, the formula could be in the other form, in the form of u and v as v or the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator divided by denominator squared. Sometimes another notation is used for our convenience as the numerator considered low, the denominator, the numerator considered high, which is the top function, and the denominator as a low function. Okay, or use the H and L. So you could use like low, D high, minus high, D low. Draw the line divided by low squared. Example 3. Using the quotient rule. Use the quotient rule to find the derivative of the function y equals x squared divided by 5x plus 1. I'm going to use notation u to represent the numerator, v as the denominator. On the side, as u equals x squared, u prime is 2x. For v equals 5, x plus 1, the v prime is 5. Use the quotient rule or dy by dx will be v du minus u dv over v squared, or the denominator times the derivative of the numerator minus the numerator times denominator prime divided by denominator squared. Or use a term like low d high minus high d low divided by low squared. Whatever formula is convenient for you. So the v as 5x plus 1 multiplied by u prime, which is 2x, minus the u or x squared times the v prime or 5, all divided by the denominator or the v or the low function squared, or 5x plus 1 squared. And after that, we simplify the numerator. 5x times 2x, we get 10x squared. 2x times 1 gives us 2x, and then minus 5x squared, all divided by the quantity 5x plus 1 squared. The numerator contains 10x squared plus 2x minus 5x squared. So the like terms 10x squared and negative 5x squared simplify to be 5x squared plus 2x divided by the quantity 5x plus 1 squared. Note that for the quotient rule, because of the minus sign in the quotient rule, the order of terms for the numerator is critical. For y equals the u over v. So by the quotient rule, y prime is v u prime minus u v prime over v squared, or in the form of the function f and the function g, that would be g f prime minus f d prime over d squared. In this case, the negative sign or the minus sign for the numerator is critical because as you recall, a minus b is not the same as b minus a. So the order is very important. In this example, for the function f of x equals x squared minus x plus 1 all divided by x squared, we are going to find f prime by A, using the quotient rule, and B, simplifying algebraically and using negative exponents. So for part A, using the quotient rule, the f prime or the dy by dx for the u and v form, the u on the top, the v on the bottom, will be v u prime minus u v prime over v squared. If u is x squared minus x plus 1, u prime is 2x minus 1. As v equals x squared, v prime is 2x. Use the quotient rule. The v, which is x squared, multiplied by u prime, or 2x minus 1, minus the u, or the quantity x squared minus x plus 1, multiplied by v prime, or 2x, or divided by the v squared, or the quantity x squared squared. And then we simplify, multiply x squared to 2x and negative 1, gives us 2x to the third minus x to the second. And similar for the second product, we get negative, put the parentheses here and apply the negative sign later. So 2x times x squared gives us 2x to the third minus 2x to the second plus 2x. And all has the negative sign in the front, divided by x to the fourth. Simplify one more time. So by the quotient rule, we get 2x to the third minus x squared minus 2x to the third plus 2x to the second minus 2x, all divided by x to the fourth. For the like terms, 2x to the third minus 2x to the third reduce. X minus x squared plus 2x squared gives us x squared, and then minus 2x divided by x squared, x to the fourth, sorry. Factor the numerator, factor x out. We have x times x minus 2 divided by x to the fourth, x power 1, x power 4. Reduce the power, becomes x minus 2 over x to the third. As a result, using the quotient rule. In part B, simplify algebraically. For our expression f of x, which is x squared minus x plus 1 divided by x squared. If you simplify algebraically, we have x squared divided by x squared minus x over x squared plus 1 over x squared, or x squared over x squared returns 1, minus x over x squared, which is minus 1 over x plus 1 over x squared. To find the derivative, we are going to write as a negative power to get 1 minus x to the negative first plus x to the negative second. And then use the power rule to find the derivative, and gives us the derivative with respect to x of 1 minus x to the negative first plus x to the negative second equals 0 plus 1 times x to the negative second minus 2 times x to the negative third, or we get 1 over x squared minus 2 over x to the third, which is equivalent to the solution that we obtained by using the quotient rule. If we simplify the quotient rule, the result from quotient rule, we would get x over x to the third minus 2 over x to the third, or 1 over x squared minus 2 over x to the third, which is the same result.